So hey everyone, in this video I'll explain the assignment problem in operational research and how to solve it using Microsoft Excel. This is a classic optimization problem used to assign the tasks or jobs to people while minimizing the cost or time. So let's get started. So first of all, we'll be understanding what is actually an assignment problem is and what is balanced. So we can see over here it's 4x4, so we can tell that it's balanced, and for the main reason of being balanced is that the matrix should be a square matrix, which mean a 4 into 4 matrix. So what really a balanced assignment problem is? The assignment problem is a special case of the transportation problem where the goal is to assign n workers to n jobs such that each worker gets exactly one job and each job is assigned to exactly one worker with minimum cost or time. So why it's important? The problem is used in task scheduling, resource allocation, job matching, or even in AI and robots. It's crucial in improving efficiency when resources are limited and needed to be assigned optimally. So over here, I have prepared a cost matrix, which means how much a worker is being paid to do a particular job. So let's take an example. The worker A is been given 9 rupees to do the job 1. Worker B is been given 6 rupees to get the job done. Worker C is getting 5 rupees. But here we have to allocate each and every job to each and every worker such that the cost or the time will be minimum. So according to here we have done the cost matrix, so we will be focusing on how the cost will be minimum. So here we can see 1 rupees is the lowest cost, and here 2 rupees is the lowest cost, here 3 rupees is the lowest cost, but we cannot assign the job 3 to B and C. So we have to find the better alternate of the B and C. So over here, the decision variable help us to find the optimal solution. Over here, we will be deciding which job will be assigned to whom. So let's get started. I have means already formulated the row and the column with this formula. You can also like this for the row. I have did this. So over here it's 0. So the particularly I have done for each and every column and row. So it won't take that much time. So now we'll be opening solver to do the calculation and the formulation as well, and setting all the constraints which we'll be requiring for solving this problem. So over here I have set the objective functions, which is z minimum and it's 0, and also we will be setting the formula over here. It's the sum and product of these two. So let's get started. I'll be opening data, then solver, then over here I'll be setting the objective. This will be the objective, and it we will set it to the minimum. So over here we will be adding the decision variable cells. By changing variable cells, which means that what we will be changing to get the optimal solutions. So over here we'll be adding all the cells in the changing variable cells, and also now we will be setting the constraints. Now we have 4 columns and 4 rows, which means we will be adding 8 constraints. So let's get started. So for the first one I'll be selecting these, which will be equal to, as we can see that in the previous video, which was transportation cost, where we can see that it was less than or equal to, but over here we will be assigning particularly one job to each and every worker, and so for that we have to set the constraint is equal to cell reference. So for the constraint part we'll be applying the supply. So yes, we got it. Now add. Now for the column part, we'll be making sure that each job is assigned to only one worker. So for that also we'll be setting the equal constraint. So now this, for the constraint we'll be adding this. So yes, we got the constraint. We have 4 cell added, and as well as we have 1, 2, 3, 4, and yes, we got 8 cell added, which means we have added 8 constraints. Now we will make the constraint non-negative. So we'll go to simplex, and then we'll be solving it. So yes, we got the solution. Now we'll be clicking OK. So here we can see that each job is assigned to each worker perfectly, and the optimal cost of the job, all the job being done, is 13 rupees. So let me fill these colors. So as we can see over here that worker A is assigned the job 1, which means it's 2 rupees. So let me do this. So for the basic of explanation, I will be adding all those things, all those job costs, so that it will be matching over here. And the worker B is been assigned job 1, so which means the worker B is assigned job 1, which is 6 rupees. 6. Worker C is assigned job 3. Worker C is assigned job 3, so which means 1 rupees. And the worker D is assigned the job 4, which means 4 rupees. So yes, we got 2 plus 6 8 plus 1 9 plus 4 13, which is perfectly aligned and matched with this. So I think we have got the optimal solution using solver, and yes, that's it. Thanks for watching. This video has been presented by Ritesh Ranjan Panda 23 BCB 7045.